the leaders of the Seattle Java user group, besides being a respected speaker and author. He has hands-on experience in developing and shipping production-ready software for industry-leading companies. He likes distributed systems, production, open source, math, Linux, and cloud environments. He is passionate about Java and is active in the Java community. He's a widely well-known open source contributor, writes a DevLotters blog, DEVELOTTERS.com, and is also active on Twitter. Jonathan, it's a privilege to have you join us today. Over to you.
Thank you very much. Thanks for the introduction. So let me share my screen and let's get started. You can see it, right?
Yes, we can.
Okay. So this is to production and beyond observability for modern Spring applications. I am Jonathan. Shafi, like said, I am an engineer in the Spring open source team. Usually I work on Micrometer, Spring Cloud, nowadays on Spring Boot as well, and a team called Spring Observability. And I am also a leader of the Seattle Java user group. And you can find my blog and my Twitter handle on the screen. That is also my Mastodon handle as well, if you are into that. So let's start with what is observability and why do we need it? And there are many different definitions. If you ask like 5-10 people about observability, maybe you will get more than 5-10 answers. Or maybe you will just get one: logging, tracing, and metrics. And we are not going to use that definition. We are going to use this one for this talk, because I think this reflects a little bit more reality. So observability really is, in my opinion, how well we can understand the internals of the system. It doesn't need to be software, but usually for us it is based on the outputs that it provides. So we have like an application which should provide meaningful information about what happens inside of it. And that is basically it. That's observability. So why would we need this at all? And the one-word answer for this is because of complexity. Because today's systems are insanely complex. We live in the cloud era. We left the LAMP stack way behind when we just had like one Linux server, one MySQL database with an Apache web server, and basically that's all running PHP. That's not the case anymore. In the cloud, this can be very complex and complicated. And if you have heard about it, the Death Star architecture or the big ball of mud, that's what I'm talking about. If you haven't, then you can search for it with your favorite search engine and look at these pictures. These are the topology, the software topology, or you can say maybe architecture of Amazon, Netflix, and Twitter 10 plus years ago. And every single node on these images is an application. And the edge between them is that they are talking to each other. Now, if you have an issue on these systems, well, it's not really easy to find out what is wrong. And also, with the law of big numbers, something is always broken. So that's basically why we need observability in a nutshell. But to make it a little bit worse, these environments can be very chaotic. That means that maybe everything is fine right now, but you turn a knob a little in one region and services are going down in another one. And also we need to deal with unknown unknowns. This means that we cannot know everything. This means that there will be issues in production that we know that they can happen. Those are the known unknowns. There will be issues in production that we know that we don't really know too much about. Those are the known unknowns. And there are things that we don't even know that they exist and they can bring down production. And those are basically the unknown unknowns. And to make things a little bit even worse, if it is still possible, things can be perceived differently by different observers. And this means that basically everything can be broken for us, everything can be broken for the users, but at the same time, maybe everything seems good to you. And solving these problems is basically like a tall order. It's not easy. So I told you about that Observability is not really logging metrics distributed tracing, or not only logging metrics distributed tracing, but they are a vital part of it, or can be a vital part of it, or your observability solution. So let's look into those a little bit, and let's look into like what Spring has to offer, if you want to like implement these. So while we are looking into it, let's first like define what are these, or give you some sense. What do we mean by these three things or three signals? So logging basically tries to answer the question, what happened in your application? And also sometimes it can answer the question, why something happened. And it is doing it by emitting events. And you can basically, like, these events usually like human readable. You can read your log message. You can grab them. Please don't do that in production. But that is basically the usual properties of logging. Metrics, on the other hand, they can try to answer what is the context of these events. And it is trying to do this by aggregating the data and giving you like an aggregate. Like, for example, one single number for 1,000,000 events that you had in your systems. And it tries to give you more information with these. And also there is distributed tracing, which should answer the question why something happened in your application. And it is doing it by recording events with causal ordering, so that you know that, hey, this event happened because this was triggered by another one, and that was triggered by the first one, and so on. So that it can answer questions like, hey, why this is failing, or why the latency is so high, and so on. But I do have a few examples for this, like two. One of them is a latency situation, and the other one is an error scenario. So let's look into the latency example here. So in this example, let's say that your logs, for example, like the Tomcat access logs, it will say that, hey, processing this very single request, it took 140 milliseconds. But is it a lot, or is it fast, or is it slow? We don't really know. We don't have the context. Metrics, on the other hand, it can tell you that, hey, the TP 99.999, it was like 140 milliseconds. And the max was 150. So within this context, 140 is rather bad in this example. And also there is distributed tracing, which can answer the question that, hey, why this took 140 milliseconds? Why this was slow? And it can answer, for example, in this example, that, hey, the database was slow. So the whole request was slow because the database was slow. And sometimes it can also give you some more information that, hey, the database was slow because a lot of data was requested from the database. And if we move to the error scenario in this example, logging, for example, can say that, hey, the processing has failed, and here is a step trace. Good luck with that. Whether it can tell you more or less information about what really happened and maybe also why. But one thing that you will not know is hey, what is the best late use? Is it everything down right now in production, or was it just like a one-off? But metrics can answer that question. It can tell you that, hey, in this example, the error rate is 0.001 errors per second, and there were only 2 errors in the last 30 minutes. So by looking at that, it's not very bad, though if those 2 transactions or 2 failed requests were the 2 $1 million transactions, you might not be that happy. But distributed tracing, it can also, or it can give you the answer why this whole transaction failed. And it can, in this example, for example, tell you that, hey, the database core failed. That's why the error basically like cascaded up and the whole transaction failed. And in some cases, it can tell you that, hey, the database failed because there was an invalid input. For example, there were like no validation in your system, but the database did some checks and that failed. Okay, cool. So with this, let's dive into every like signal, like logging metrics and tracing here. And let's see what is in Spring, what Spring can offer to you to implement this. So if you want logging with Spring, Spring Boot comes with SLF4J and Logback, and it is pre-configured for you. SLF4J stands for Simple Logging Facade for Java, and it has a simple API, and you can plug like logging libraries in and out. And Logback is a native implementation of this SLF4J API, and this is what Spring Boot comes with out of the box. You can replace Logback if you want, for example, to Log4j2. In order to do that, you just need to like exclude one dependency and include another one. And basically that's all. Spring Boot will take care about the auto configuration for those. Also, there are other types of logs that you can use. And this slide is a little bit outdated, and I need to also update my application as well. Because if you want to use payload logs, there is a project called Logback, which has a Spring Boot starter. And it wasn't available for Spring Boot 3 earlier, but now, as far as I know, it is. I used it for Spring Boot 2, hasn't tried it with 3, but it should work. And what it does, basically, it will, every time when you receive a request and send back a response, it will basically put this information, the whole request and response, into logs. And the same is applicable for HTTP clients. So whenever you send out a request and receive a response, those can go to logs as well. Also, you can turn on access logs for your favorite servlet container. These supported are like Tomcat, Jekyll, and Undertow with Spring Web. And you can just enable those by just a single config flag. And also there is GC logs. Spring doesn't really have anything to support there because these are like JVM features, so that you can turn them on and off with JVM arguments. And let's move on to metrics, and let's see what Spring has to offer if you want to implement metrics. So if you want metrics, the support for metrics in Spring, the answer for that is Micrometer. Micrometer is the most popular metrics library on the JVM. And we like to say that it is like SLF4J, but for metrics, because it has a simple API and it supports the most popular metrics backends that you can use. And Spring Boot Actuator comes like pre-configured with Micrometer. So if you are using Actuator, you will get Micrometer for free, and it is auto-configured for you. And also Spring projects are instrumenting themselves using Micrometer. And there are a lot of third-party libraries that use Micrometer to instrument themselves. And not just libraries, frameworks as well. So if you're using Corpus, it is using Micrometer to instrument itself. If you're using Micronaut, that also has Micrometer support. Hibernate, Icarus CP, the list is very, very long. And when we say it's like SLF4J, but for metrics, this is kind of what we think about, because these are the backends that are supported by the Micrometer team. There are more backends than that are like supported by some third parties. So you can use Micrometer with more backends than this, but these are basically the core that the Micrometer team supports. And you can use Prometheus, you can use like your favorite like cloud providers, monitoring solution, OpenTelemetry, StatsD, whatever it is you want to use. It's usually supported by Micrometer. But with this, let's move to distributed tracing. and what you can do with what you can do to implement it with Spring. And we need to make a slight distinction here, because if you are on Spring Boot 2, then if you want to use like distributed tracing, then the answer for that is Spring Cloud Sleuth. But if you are on Spring Boot 3, the answer for that is Micrometer tracing. And these are just like libraries. And Micrometer tracing is basically the same as Sleuth. We just copy-pasted most of the code base of Sleuth under the Micrometer umbrella. We renamed a few things, fixed some other things, and basically removed the Spring dependencies. So Micrometer tracing can be used alone, even if you are not using the Spring application. It can be used in any Java apps. That is not true for Spring Cloud Sleuth. Spring Cloud Sleuth needs a Spring Boot app. It depends on it, but Micrometer tracing is not. But what is similar in both of them is that they are trying to provide an abstraction layer on top of tracing libraries. So this is kind of like the SLF4J situation, where you can plug these libraries, these tracing libraries, in and out. And we support two right now. One of them is called Brave from the OpenCPN community. And this is a mature project, and this is kind of like the default choice for us right now. And there is also OpenTelemetry, which is a CNCF project. And this is kind of experimental because OpenTelemetry is not stable yet. And also we have instrumentation for Spring projects, and there are third-party libraries that are also instrumented. You can instrument your own application. And because of these two backends, these two libraries, these tracing libraries are supporting various backends. Micrometer tracing and Spring Cloud Sleuth as well, they are supporting various backends through them. So now let's dive into this thing called the Observation API. And this is, I guess this is a very important part of the whole presentation. And also let's talk a little bit about the Spring Observability effort. So if you have your application, and let's say that you have like some components, some business logic, maybe in-house big libraries, I don't know, some code base. And let's say that you want to instrument that. The issue with that is that you need to do like things kind of like multiple times. You need to instrument your application and add some logs, for example, like application logs. You need to add some metrics, which means that sometimes you will increment counters, sometimes you will start and stop timers. You will add distributed tracing by starting and stopping spans, implementing log correlation and context propagation. This is a lot of things. Like here, you at least like doing like 3 things. And also maybe you will need custom things as well. Like if something happens, you might want to like write some records into a audit database table. So that's 4. And you can, this list can grow, and this can be like kind of like boilerplate. Maybe your business logic is just 1 line, but your instrumentation code is a lot because you need to do the same thing multiple times. And we tried to fix this. And the answer for this is the Observation API. The Observation API is available since Micrometer 1.10, which was released like in 2022 November. So a little bit more than 6 months ago. What it does, basically, when you use the Observation API, you will not say that, hey, I want metrics, logging, or distributed tracing, or whatever else you need. You're just saying, I am observing this code snippet or this part of the application. And you can do this by saying that, hey, I want a observation, and let me start that observation. Let's have this name of the observation, and I am observing like a thread.sleep here. If there was an exception, let me signal that exception. And at the end, let me just stop the observation. So basically, that's it. There are like multiple things that you can do, but you are just starting it, stopping it, and you are like adding like additional information. For example, an error happened, or arbitrary key values, whatever you want. But with this, you don't really know like what will happen with the data that you recorded. And the answer to that is called observation handler. And the observation handler is a key component in the observation API. Basically, it's a part of it. What you can do is when you want to create an observation, you always need an observation registry. And in this observation registry, you can basically like register these handlers. And these handlers is, if you will, these are kind of like listeners that will be notified whenever somebody starts an observation, whenever somebody stops it, signals an error, signals like arbitrary events, and so on. So with this, if you have these, if you can receive these notifications, you can, for example, write a meter handler where you, for example, start and stop a timer when somebody started and stopping an observation. Except you don't need to write that because we are giving that for you. We have like a default meter handler in Micrometer that does exactly this. And also you can have a tracing handler, which basically starts and stops spans whenever somebody starts and stops an observation. And that is also provided by Micrometer for you, and it is called default tracing handler. You can also like write a logging handler. Micrometer has something similar, but if you don't like it, you can write your own. It should be like very, very simple. Or you can do custom things like an audit event handler. When you receive the data and say, hey, somebody started an observation, let me write that data into a database table, or whatever you want. The word here is basically your oyster. There are a bunch of things that you can do. So basically, the observation API provides you the possibility to instrument your application once and get multiple benefit out of it later, whatever you define at runtime. And that is basically it. You just start an observation, you do your thing, and you stop it, and these handlers will be notified, and they will basically like process the data and emit whatever output you want through them. And we have a couple of like shortcuts to do that. Like you saw that start, stop, and like signaling error. Sometimes it can be like considered as boilerplate as well. You can have full control over that, but if you want like something simple, you can just say that, hey, I am creating an observation. I am not starting it yet. I am attaching like arbitrary key values. You can do that with the previous approach as well, but it wasn't there because it did not fit to the slide. But this is very important here. Here I'm saying just, hey, I'm observing like a method. And this is basically a method reference, and that's all. So whatever you saw like 2 slides ago is basically the same thing as this, but in just like one line. Hey, I'm just saying that data observe, and this will like start an observation, stop the observation before and after this method, and also it will signal an error when this method like to an exception. And also there is an even simpler approach, which is the observed annotation. You just put that onto your method, and it will start and stop an observation for you and signal an error whenever it is needed. So with that, let's go and let me show you some demo, and let me show this in action. And we do have an application for this. It is not very complicated. The whole thing called T-Service, or the T-House application. And the first like application that basically the users are interacting with is called T-Service, which is calling TLeaf service and water service. And TLeaf and water, they have their own databases. So there is a TLeaf database and there is a water database accordingly. And all of these services, they are also reporting like themselves, they are registering themselves into Eureka, which is a service registry. And there is also Spring Boot admin, which talks to Eureka, and it shows you like, hey, these are the available like applications on a nice UI. And this is basically what we have in these apps. So these are like just MVC applications, they are using JPA. The T service is using OpenFame as an HTTP client to call the other two. We are using like Spring Boot Actuator so that we will have Micrometer support with the observation API. And Spring is like the Spring projects are basically like instrumenting themselves using this observation API. So that was kind of the Spring observability effort that we did with Spring Boot 3 and Spring Framework 6, is that we basically moved out the instrumentation to the place where it belongs. So for example, the Spring MVC instrumentation with the observation API, it happens in Spring Framework in MVC and so on. We are also using Prometheus. You don't need to. It is just like a easy thing to set up for this demo. And we are using Micrometer tracing with Brave. And we are going to use the Zipkin reporter. And also we are going to use another project which is called Data Source Micrometer Spring Boot. And this is for instrumenting JDBC. There is also support for R2DBC if you are into that. And also for Webflux, Spring integration, Spring data, and so on. All of these projects are instrumenting themselves. But these are basically the key components that we are going to demo today. So with this, let's try and make some tea with this application. So this is our UI. It has like options. You can basically pick the tea leaf, the amount of water that you want, and let me say that I want to brew like a small sandshot. And if I click the button, I will get basically the recipe. Or let's say I want to like drink a large English breakfast. And if I just click the button, then I am getting an error. And this is bad. So what happened? We don't really know. If I click the button like multiple times, it is still down. If I pick another T, it seems it is okay. So what should we do? Like, how can we start basically like debugging this or troubleshooting this application and trying to figure out like what really happened, and also like how broken is it? And in order to like answer this question, again, we have like Micrometer under the hood on these applications. So they are basically, we have like logging metrics and also distributed tracing setup with these components. So I created a simple dashboard here. And if we look into this panel, this is throughput. So what you can see here is that the amount of like traffic for the T service. And there is success and error here, as you can see, and ironically, error is green and success is yellow. But what you can see is that we have kind of like a steady stream of errors. It's kind of like 0.565-ish per like request per second, and there are 4.5 per second that is success. So this is kind of like 10% of the requests are failing, which is like bad a little bit, but it's not the whole thing that is down. Okay, so let's so now we know like that the application is not really working. 10% of the requests are failing. It's still working a little bit, but not a lot. So let's try to get like a little bit more data. So let's try to look into logs, for example. And if I search for logs for this whole T-House application, let's see in the last like 5 minutes. And let me just zoom into this. Let me try to find an error. Here, this one should have one. It doesn't. Okay, let me try to find another one again. here. Yes. So here's an error with a stack trace. So what this is saying that, hey, at this time, an error happened, the T-service emitted that error. And the error message basically says that there was a GET request to this endpoint, and it was 404 not found. And this was like a resource not found exception, which is a little bit more details. Now we know that this is a 404, coming from maybe the TD service, but we don't really know why this thing happened. And the first thing I want to demo with this is how easy to jump between these signals, because this is now the point when we know the blast radius, we know what happened, the application is broken, but we don't know why. So we would like to now jump to distributed tracing to figure that out. And Micrometer, based on the data, lets you do that. So because you have these three signals, you can jump between traces and logs with a thing called trace ID. And here, let me tell you some terminology, because this is rather important. So in distributed tracing, basically the atomic operation that you would like to observe, that is called a span. A span is basically something that happened in your application and you want to know that that thing happened. And these spans, they can have like parent-child relationship. So that's the causal ordering. So, hey, this thing happened because this was triggered by another one. And so these spans, they can belong to each other. So they can have basically like a tree-like structure. And these spans that basically are grouped together, they are called traces. And every single span has a ID, it is called a span ID. And this whole thing, the trace, it can also have an ID called the trace ID. So what we can do, we can get these IDs, for example, the trace ID, and we can put that ID into the logs. And that is called log correlation. And that's what we have here. So if I go back and zoom into the logs, what you can see here is that we have the T service here. That's the name of the application. And this big number here in hex, that is the trace ID. And this smaller number here in hex, that is the span ID. So what I did, I basically teach Loki, which is like Grafana's logging solution, but you don't really need to use that. You can do like whatever logging solution you want. I teach Loki to grab that trace ID out of the logs. So it is available for me here as well. But it is in every log message. So you can just basically like get this like ID, the trace ID, copy it, go to your distributed tracing backend and paste it there and search for that. So that's how you can basically jump from logs to tracing. But Grafana has these things like these backends integrated. So I don't need to do copy paste. I can just press this button. And I am now looking at the trace. So this is a lot what you can see here, but let's look into this a little bit. So basically what you can see here is two things. One is like a tree-like structure. This is basically your core stack. This is what happened in your application. And this is basically a timeline of it. So let's look into this, this first one first. So you can see that, hey, there was an incoming HTTP request to this endpoint, to the T service. And by the way, if you look into this like red thing, you can also tell that, hey, this failed. And then the T service, it is emitting a HTTP GET request. And it seems the voter service, it received that HTTP GET request on this endpoint. And then the voter service made a database connection. To the voter database, it executed the query and then processed the result set. And then basically the same thing happened with the T service. The T service basically like called it on HTTP. It was an HTTP GET request to this endpoint, and again database connection, executing a query and processing the result set. And what you can see here is that there is another red button, which is suspicious. It basically indicates that in this core stack, the T service failed, probably because the TLEAF service failed. So let's look into that. So let's look into the details. And let's start here. Let's look into the attributes. What else we know about this whole thing? We can see that this was an error. With this error message, we saw that in the logs. This was a not found exception to this very URL. This is the full URL that you can have. And this was a GET request. This was the host name. This was a server error. And it seems that T service gave HTTP 500 back to the user. And you can also have the templated URI here. So this parameter here is basically like templated into the name of the parameter, which in this case called the name. Okay, so that is something we know a little bit more about this whole thing. Let's look into the HTTP request that this service made. So this was GET request to this host, and this was to voter service, and this was HTTP 200. This is not very interesting right now because this was totally fine. It did not fail. But let's look into what happened with the TLEAF service. So again, there was an HTTP request, and this ended up with 404, this HTTP client request. So let's dive a little bit deeper and let's see what happened with the TLEAF service. And you can see that, hey, resource not found was, this was a resource not found exception to this endpoint, this host name, and this was a client error saying 404. So now we know that the TLEAF service, it basically said 404 to the T service, and the T service basically mapped that 404 to like 500 and told the user that, hey, this was a 500, which is, whether it's good or bad, it's up to you, but that this is what happened. So let's see what happened with the database. And it seems that this was like a database connection on this host to TLEAF using the MySQL JDBC driver and Hickory pool. And it seems that this was fine. And also, oops, I just closed it. Also, there was a JDBC query to this very same database on the same host. And it seemed that this was the query that was executed. I'm sorry, this is not very readable. I did not write this query. This was basically written by Hibernate. And what happened here is that basically this is a select query where we are selecting the ID, the name, the suggested amount, and so on, a bunch of things from the TLEAF table, where the name of that TLEAF is here, English breakfast. So basically what you can do, don't do this in production, but what you can do is basically you can go to this database host, log in, use this DB, and you can execute the select query, and you can check what happened with the database, what was the result set. But we have some information here with the result set, in this case, this one. And this might be a problem, because this says that JDBC row count is 0. So the database basically returned an empty result. And that's a problem. That's why, that is very, very likely. That's why basically we are getting 404 back from the TLEAF service, because it did not find the record for English breakfast in the DB. So the record is missing from the database, and it is like intentional. This is a demo, but let's try to fix this. Let's see what happens if we basically put that record back to the database. Will this this error disappear or not? And let me do that. And let me just send an HTTP request to the TLEAF service, and let me add English breakfast to the database. And let me send this. And I got like HTTP 201, it was created, which is good. So if I go back to the UI and I say, like, let me improve some English breakfast, then now it's success. And we can verify this with the metrics dashboard, but it will need some time to populate with data. So before I would do that, let me show you another thing, because what we did so far is basically we jumped from logs to traces, but we can jump the other way as well using the trace ID. So if I go back here, I can basically like copy paste the trace ID here, and I can go to the logs and search for that. But since Grafana is basically like integrated, I don't need to copy paste here. I can just press this button. And what happened is basically Grafana created a search query with this trace ID. And I can see all of the logs here, and only those logs or log messages or log events that belong to that single trace. And this is kind of like the same view or the same amount of data or view of the same events what you saw in the trace view. So I can see here that, hey, there was a call to the T service, and this was like a get call to this endpoint. And there was like a T service made an HTTP call to the voter service. This was the database like query that voter service made. And then there was a call to the tleaf service. And this was the database query that the tleaf service made. And then we got this exception. First from the tleaf service and then from the T service. And with the timeline and with the like the tracing view, that is a little bit like easier to do the same thing, but you can get like some kind of similar data with logging as well, except this is like not as like efficient. You will end up with a lot of logs. But I promise to you that I will show you that this is hopefully fixed. And also, yeah, so if you like look into this, what you can see is that we had like some server errors, and now it is going back to 0. Now we don't have any errors, and the UI is working. I can sleep like English breakfast. So that's good. We basically like troubleshooted the issue and figured out like what happened. So is that all? Can we go home? It's like we are done. The application is working again. Can you spot any other issues? And yeah, this talk should be like 1 hour. So yeah, of course, there is like another issue here. If you look into the latency graph, now you can see that the latency is spiking. And this is not good. You can see that there was like TP99, TP95, and the maximum latency here. And the max latency was like around like 40, 60 millisecond. TP99 was like much less. It was like around 30. But then the whole thing jumped up. And now we are at like around the 200 milliseconds range, which is like a significant change. So how can we basically like troubleshoot this? What can we do? Again, we can go to metrics, and we can look into our dashboards. We can check like, hey, what is happening with the application? What is happening with the JVM? Is there any problems? And Micrometer basically gives you a lot of data out of the box about your apps. So what you can see here is that the heap usage is great. Non-heap usage is not bad either. That seems good to me. The CPU is basically sleeping. We don't have a bunch of load. GC is kind of constant, but not very frequent. And this is also like minor GCs. This is Eden. We are using G1 here. So there is no problem there. Old gen is basically constant. So GC is cleaning up most of the things in the young gen. Non-heap, there are no changes here. We have a bunch of classes that are loaded, but this is not like not terrible like this number. Also, like these are like the direct buffers. This is for like native heap. There are not a lot of things here. We only have like just a couple of threads. This is not bad either. Here are some like other GC statistics. The stop the word duration is in the like microseconds range. So that's definitely not why the application is slow. We don't have a lot of GCs. You can see that this is like 0.1, the GC rate. And this is like very, very sparse. Yeah, this is the same throughput graph that we saw in the previous dashboard with the errors and the successes. And this is the same like latency graph. So based on this, everything seems good and everything seems okay. So metrics here, it can tell you that, hey, we have some latency. It is rather bad, but it is most probably not the JVM. We don't really see anything bad on the JVM side. So what can we do with this? And again, we can get like distributed tracing in order to answer that question. So what we can do again, we can jump between metrics and distributed tracing, and we can jump like in both ways. So one way is easier than the other. We can jump from traces to metrics because usually when you use the observation API, the tags for metrics and traces, at least the low cardinality tags, they will be the same. So basically, if you look into your trace, or you can just get a span, you can get all of the tags that are available there. And basically, you can use them to make a query because the keys and the values of the tags will be the same for your metrics. And this is not very like hard to do. You can basically just copy paste these or teach your tool to do that for you. The other way is much more difficult, getting from metrics to traces. There is a solution for that called exemplars. And the problem here that you need to face is basically you have like, I don't know, like 1 million data points that you aggregated into like one single number. Like, hey, this is the throughput or this is the latency. How can you get like a sample data point out of that 1 million that contributed to this one number based on that one number? So you just say that, hey, the latency is 200 milliseconds. How can you get an example data point that contributed to that 200 milliseconds? And the answer for that is exemplars. And exemplars are kind of like metadata that you can attach to your metrics like data points. And they can basically tell you, you can attach a trace ID and a span ID to your like metrics data points. And that's what we have right now. If I zoom into here, what you can see is that the graph, and there are basically every once in a while these data points here. And this is an example. What you can see here is that this very sample or example data point, it took 174 milliseconds to process it. And this was a success. And this is the span ID and this is the trace ID. So what I can do, I can copy paste this trace ID and I can jump to the trace view with that. And another thing I can do is if I just go here and copy this trace ID, which belonged to a request which was like rather fast, and also get here and jump to tempo, I can see this whole thing. Now, what I can do, I can basically split the view and I can paste the trace ID that belonged to the slow request, to the fast request. So I can see both of them side by side. So on the left side, what you can see is a sample, an example, like a trace that took a long time. Like you can see that this was like 175 milliseconds. And on the right side, what you can see is a trace that belonged to a like request, which was fast. This is just 34. So what we can do, we can basically visually diff them. We can see the timeline and we can see also the call graph with all of the latencies. So we can basically like dive into this and check that, hey, This whole thing was 174, this was 35. This took 174 because this one took 161 here. Maybe it will be a little bit more visible if I not looking at the timeline, but looking at the tree view. And I can just see that, hey, this was like the call to the voter service. This took like 161 milliseconds. And if I go here, this was just 25. And if I look into the T service, the fast was like 7 milliseconds. And here it was like 10, which is not a big deal. But here I can see that this is a huge difference. And if I go like deeper, I can see that, hey, the database call here was like 50 milliseconds. And this was just like 20. So what I can do is I can basically go back to the metrics. And now that I know that probably this is the database of the voter service, I can just select the voter service application and I can check the database metrics for that. And as you can see here, the database like latency went up, which is bad. We do have like higher latency for the DB service. And this happened because I like intentionally injected latency, calling a like thing called taxi proxy. And what it does, I am not like calling the database directly. I am calling it through taxi proxy, and I made the network slower intentionally. If I remove that and I fix that, then the metrics should go back to their original latency or around that. And the last thing I wanted to demo with this is that jumping from tracing to metrics. And as I mentioned, you can do this with like common tags. You can see all of the tags available here. So I basically can craft a query in my metrics backend, including these tags, but I also teach Grafana how to do it. So I can just click on this and I get metrics to throughput, or I can get metrics for latency. You can see, by the way, that it is going back, but I will show that on the dashboard too. So that is basically it. We were able to troubleshoot our application in a latency and in a like error scenario as well. And yeah, now latency is going back. If we will give like more time to the service, this will go back to its original flow, which is like around like the 15 milliseconds range, which is like much better than this 200. So because of that, because if you can jump from metrics and traces and back, and also traces to metrics and back, you can also jump from basically like logs to metrics and metrics to logs through traces. Not directly, but if you stop at traces, you can jump to the other signal as well. And the last part I wanted to show you is that this is not all. So this was basically like logging, metrics, and distributed tracing that we used, but there are many more things in Spring Boot that you can basically use. And one thing is called like Spring Boot Actuator that gives you a lot of details about your application. For example, health details, or like a bunch of info, like when was this built, what Java version are you using, what operating system, what cloud environment are you running, CPU, memory, which GC was selected, and so on. There are a lot of details here that you can use. And also, you can use service discoverability and API discoverability for for observability. So basically, if your services are registering themselves, you can have a view of like, hey, these are the applications that I am running. And you can, this is Spring Boot Admin, which is basically like a nice UI on front of like Spring Boot Actuator or the Actuator endpoints, and you can see them. I'm not going to do that, but basically that's the gist of it. And it gives you not just a list of your services, like of your applications, but you can also like get more details about them, looking at these endpoints. And also you can get information about like how to call or use these applications. And there are projects for it. Like, for example, like there is Spring RESTdocs, which is like generating your documentation based on your tests. There is also like Spring Cloud Contract and the Pack Broker, which will give you like contract testing between your server and client. And also the Swagger UI, you might be familiar with it, which will give you basically an API browser and an HTTP client. And the last thing I want to show you is Spring HateOS. And there is also a whole Explorer, which is also kind of like an API browser and an HTTP client. And Spring HateOS is basically a project for a like REST HateOS. And HateOS stands for Hypertext as the engine of the application state. And this is a mouthful, but what it does, it can give you kind of like extra links into your responses, REST responses. So here what you can see is like a request to the tleaf service. Hey, give me all of the tleafs. And this is like one tleaf here. And what you can see here is this is the ID of it, the name, the type, and so on. But what HateOS does, it will give you these extra links. For example, hey, this is how you can query this one single tleaf. And if I just click on it, I don't need to know how to do it. I just click the link, I just follow the link, I will get that. So now I'm querying this single tleaf by that ID. Also, since this is a paginated output, you can get that information too by HateOS. You can see that the page size is 20. I have total elements of 3. I have just one page because like that 3 elements can fit into one page. But if I just set the page size to, let's say, 1, I will get extra links here. I can see that, hey, this is the link to the first page. And by the way, I am on that page. And I can get a link to the last page. I can get a link to this page I am on right now, and I can get a link to the next page. And if I follow that link, I am now on the second page, which by the way gives me like extra links. This is the previous page as well. So basically with these, like previous and next, I can iterate through all of the resources, and I can just follow this and just go next, 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 until there is a next. And I will get the next resource, the next resource, the next resource. You don't need to implement this on your own. You just need to follow the next link until there is a next one, because if there is no next, then you know that you are at the last one. So that was basically it. If you want to like increase developer productivity, this helps you a lot. Not just HateOS, but all of the things that I showed you today. So with that, like thank you very much, and you can find my Twitter handle and my blog here on the side, and also this is available, the whole thing I showed you, on GitHub. So you can basically try this out and play with it if you want to. And if you have questions, please let us know.
Right. No, Jonathan, firstly, I think thanks a lot for a brilliant session. Really, really interesting. I think the parts that I liked are most of this functionality. If you go to a product like New Relic and stuff like that, you would get some of this functionality, but to see that this is available within Spring, that's amazing. Yes. Right? So you don't have to like really depend on external products and write the glue code, all of that. So
the interesting thing here is everything I showed you today, none of them basically needs like I just demoed it through Grafana, but you can use any backend that you want, and gives you this functionality.
Right. That's amazing. Thanks for doing a great session. I had one question, but I think you more or less answered that on by showing that thing on your slide. Most people were interested in looking at the code, but yeah, I mean, you have already pointed them to the GitHub thing. But yes, an amazing session, and we would hope to bring you back for another session soon.
Cool. Thank you very much.
Thanks a lot. Have a great day. Bye-bye.
Thank you. You too. Goodbye.